And then, if you think about a plane and transformation of a plane, now we are coming to the last example. You take some shape, and then a vector field deforms it into a different shape. Right? Now, don't you have some information just from this picture of how deformation happened? Right? So you have a feeling that you see that, well, the whole thing is rotated by, roughly speaking, what, 45 degrees, right? Well, a little bit smashed here, smashed there, but not much. So the volume is approximately, the area is approximately the same. So you have all these kind of feelings, right, about the picture. And the feeling is coming only from the picture of the boundary, right? I'm not telling you anything about what happens inside. And that's exactly the boundary part of the statement. That you can pick up some information from the boundary, and it's exactly the same as if you integrate something else on the inside. And the calculus tells you exactly what kind of information you can pick up. Right, so this integral over the whole region for a vector field f, it's going to be an integral of a matrix, right, 2 by 2 matrix. And then integral of a matrix is going to be a matrix again, so it's 2 by 2 matrix as a result. Basically, that matrix tells you that if you were to deform this into that linearly, kind of on average, this is exactly the matrix you would apply. A matrix that would rotate this by 45 degrees, a little bit stretch, a little bit compress, but that will be exactly the kind of information you can visually pick up from the picture. Stated precisely in form of 4 numbers. You cannot learn anything more and neither less. That's exactly what you can. All right, now having that in mind, you see, in this kind of examples, it seems sort of easy thing, right? It's very kind of practical interpretation, and you intuitively feel what happens and what the fundamental theorem of calculus says, and there is no big surprise in that, right? So the surprise, I believe that surprising points come when you take the fundamental theorem of calculus and you interpret it in a different way. When you look at reality and you find examples when this theorem applies and tells you something totally new, totally unexpected. So let me go back to Richard Feynman. So he will talk about seeing things.